question, there is an inclined plane at an angle 30 degree. 10 kg block is here, 10 kg block is here, and over here now the pulley is not massless as it had been when we had been doing the Newton's laws of motion. Now pulley has got some mass, it has got some inertia. I is 5 kg square about this axis and radius is 1 meter. The system is released from rest and we are asked with what velocity this is going to strike the floor. So now let's attempt this question using dynamic principles. That is, we are going to talk about the forces, we are going to talk about the torques, and then we are going to relate, that is how the translational motion is related to rotational motion. For this 10 kg block, this is 100 Newton is over here. We say T1 in this string, T2 in this string. Had the tension been same in both the string, this pulley would not have rotated, but this is rotating. We know that is T1 is going to be greater than T2. So it is 100 Newton here, T1 here. Equation comes out to be 100 minus T1 is equal to 10 into A. For this, T2 is in this direction, mg sin theta is going to be in this direction. M into g into sin 30. That is 50 Newton is in this direction. So for this block, so this is T2 is in this direction, 50 Newton is in this direction. T2 minus 50 is equal to 10 into 8. This is our equation. Translation equation, translation equation. For this it is purely going to rotate. If this is going to rotate over here, we have used F is equal to ma. That is net force equal to mass into acceleration. This is rotating, so we shall be using net torque is equal to y into alpha. If we draw the force diagram of this, this is T1 this way, T2 this way, both the tangents, so that is going to angle 90 degree. So this 1 meter, this 1 meter, it is rotating this way. So equation for this is net torque T1 into R minus T2 into R is 1 meter is equal to I. I is given as 5 kg square into alpha. Also, whatsoever the acceleration of this, the same of acceleration of this, same of acceleration of this, same of acceleration of this. So we can use also A is equal to R into alpha, that is A is equal to 1 into alpha. So we have, how many equations we have? We have 1, 2, 3, 4. We have 4 equations. And how many unknowns we have? We have T1, A, 2 unknown, T2, third unknown, alpha, fourth unknown. We have 4 unknown, 4 equations. Obviously, we know that is how to solve these equations. From there, we can get the value of A. Once we get the value of A, we can use V square minus U square is equal to 2AS and we can get the answer. So as we had done earlier, we can just write the equations. In this equation, T1 minus T2 is equal to 5 into alpha, and we can use A is equal to R alpha, A is equal to 1 into alpha, and we can get this equation. When you add these 3 equations, minus T1 and T1 will get cancelled, T2 and minus 2 will get cancelled. 100 minus 50 is 50, 50 is equal to 25 into A, you find the value of A, and then you can use equation of kinematics, V square minus U square is equal to 2AS to get the answer. Let's do it using conservation of mechanical energy principle.